This episode is brought to you by Cisco Educational Premium. To really see the big picture and understand this, we need to map this hyperbolic plane to infinity. We'll start with a circle, then we'll fill it with a set of circle segments that all intersect the circumference at right angles. Those circle segments represent the straight lines of the hyperbolic geometry projected onto the disk. We can see the hyperbolic behavior of these arcs. They are geodesics, the straightest possible paths in this geometry. Any two paths that are parallel to one another at one point will diverge from each other in either direction. This is a conformal transformation of hyperbolic surface because the angles of intersection of these surfaces are preserved and is compactified because an infinite hyperbolic surface fits on a finite disk with lengths represented by shorter and shorter arcs towards the rim. The other feature of this conformal mapping is that shapes like triangles are preserved, at least locally. We see that we fill the circle with triangles which only vary in size but not in shape. An example of tessellation. This disk is what we call Poincaré disk model. In 1832, 9 years after he discovered this strange new universe, the hyperbolic plane, he publishes his finding as a 24-page appendix to his father's textbook. Extremely proud and excited, and maybe a little jealous of his son's work, Farquhar Cloutier sent the textbook to the great Carl Friedrich Gauss. After careful examination, Gauss replied a few months later, and I quote, "To praise it would amount to praising myself, for the entire content of the work coincides almost exactly with my own meditations, which have occupied my mind for the past 35 years." Years earlier, Gauss had wandered a similar path. In 1824, he discovers a curious geometry, one with paradoxical and the uninitiated absurd theorems. For instance, and as he quotes, "The three angles of a triangle becomes as small as one wishes, if only the sides are taken large enough, yet the area of the triangle can never exceed a definite limit. We can have a triangle that is infinitely long, but the area is finite. In the hyperbolic plane, a small triangle looks ordinary, but as we make it bigger, the angles becomes smaller and smaller, approaching zero, because all the lines intersect the disk at 90 degrees. The sides of the triangle are infinite, but the area is finite. Isn't this incredible?" In the same private letter, Gauss wrote, and I quote, "All my efforts to discover a contradiction and inconsistency in this non-Euclidean geometry have been without success. Just like Cloutier, Gauss had found this geometry seem thoroughly consistent. He named it non-Euclidean geometry as opposed to Euclidean geometry. This new geometry described a mathematical world where Euclid's first four postulates hold, but the fifth doesn't. But Gauss never published his findings for the fear of ridicule. On a sphere, straight lines are parts of great circles. These are circles with the largest possible circumference. These are the equator and the circles of longitudes. This means that on a sphere there are no parallel lines, that is, those that do not meet. Until 1854, spherical geometry wasn't actually considered a non-Euclidean geometry. This because on a sphere, lines cannot be extended indefinitely. This had been encountered and dismissed by early mathematicians, since Euclid's second postulate would not hold. However, in 1854, the great Riemann changed the second postulate from an infinite extension to something referred to as unbounded, so that the second postulate still hold on a sphere. While Euclid was right in postulating the fifth postulate, he did make a different mistake. The mistake that he made was that he defined the first four postulates. Things like what is a point, what is a line, what is a straight line should be undefined. This because they are emergent properties. The relationships between objects is more important than giving a definite definition of the base postulates. In other words, mathematics have to start from nothing, from undefined terms. It's quite philosophical if you ask me. That is, it doesn't matter what a thing is. What matters is only how useful and practical it is. So beautiful. Cisco Educational Premium is a section of Cisco Educationals with content that is not hosted here. There are episodes ranging from long to short videos. Remember those good old shots of ours? They are there. So how do we get there? Use the link on screen or in the description or in the pinned comment below. Enjoy yourself. And I will see you in the next episode of Cisco Educationals.